Hello everyone, this is Prashanth. Let's continue with the last lecture here. Today I am going to explain IoT system management with network configuration YANG module. So before that, just once we recall at least for 5 minutes what we discussed in the last lecture. So in the last lecture, IoT device management system, device management, device management system along with IoT system management system. So, what are the specifications? What are the specifications of IoT device management system? Specifications. What are the requirements? What are the requirements of IoT device management system? Next, what are the advantages and disadvantages of IoT device management system. So these are the things we discussed in the last lecture. So now we move into the new topic, that is IoT system management with NETCONF. NETCONF means network configuration along with YANG module. So network configuration is different, YANG module is different, that can be developed with through the network configuration mode. So let's discuss with the introduction point of IoT system management. So it is having different components here. uh, IoT system management API, application program interface. Next to transaction management, how the transactions can do within the module. Next to rollback manager, what is the main role of rollback manager, what is the backbone of the network. Next to data model management. Next to configuration validator, in order to configure the configure the data, is whether it is valid or not valid, that can be decided by configuration validator. Next to configuration database. So in order to store some information, just we need one database. So from this is the database. Next to configuration application program interface along with the data provided application program. So these are the nine components, basic components of IoT system management. Along with this is the diagram. So the main role of this diagram is management. Under management system, we have different network configuration server. So here this is YANG module from to the configuration database. So here management system with the network configuration, the data lines just it is include under network configuration server. So in this include management API, transaction management, rollback manager, data model manager, configuration validator, authentication, authorization, and auditing modules. This connect to the IoT device that is managed by object. We are going to develop some application, that is application status, statistics, performance, alarms, and counters. This is the IoT basic block diagram of IoT device management with the network configuration with the YANG module. Let's discuss with the point by point. So management system. Management system, in order to manage all the things of under the system. So the operators uses a management system to send a network configuration message to configure the IoT device and to receive the state information and the notification from the devices as a network configuration message. So these are the things can do by network management system of IoT device management system. Next, second one, management API, application program interface. It allows management application to start a network configuration session. So in order to begin or in order to start the network configuration session, just it can followed by management application program interface. Next, transaction manager. What is the main role of transaction manager? Executes all the network configuration transactions and ensures that ACID properties hold true for the transaction. So this is the main role of transaction management. Next, rollback manager. What is the main role of rollback manager? He is responsible for generating all the transactions necessary to roll back to a current configuration of its original state. So this is the main role of rollback manager. Next, data model manager. So it keeps track of all the young modules that are corresponding to managed objects. Also keeps track of the applications which provide data for each part of a data model. So these are the first five components of IoT device management system. Next, configuration validation. Configuration validator, it checks if the results configuration after applying a transaction would be a valid or not configured. Next, configuration database. So it contains both configuration and operational data. It consists two types of data. First, you can configure. After configuration, just we have to verify with operational data. Next, configuration API. Using the configuration API, the application on the IoT device can be read configuration data from the configuration data store and write operational data from the operational data store. That means, so here two databases here. One is the configuration data can be verified by the configuration data store. Configuration data store. Next, operational data. Operational data can be confirmed by operational database. Operational database. Operational database. So these are the things can be done by configuration API. Next, the last one, data provided API. The applications on the IoT device can register for callbacks. In some cases, it register for callbacks for various events during the data provided API. So through the data provided API, the applications can report to statistics and operational data. It can do two things here. Statistical, it can report the statistics report and operational data. So these are the things can be done by data provided API for the IoT device management system. So these are the things of IoT system management with configuration data. So it include various components like management system, management API, from management system to data provided API. So these are the components of network IoT system management with network configuration. So configuration. Next, it is the network configuration black diagram here. The previous slides, the components it having. So it is the main black diagram of network configuration here. So it is a session-based network management protocol. So network configuration is a session-based network management protocol. So it allows retrieving state or configuration data and manipulating configuration data on network devices. So this it is here, it is the from the client. So from the client we have different components like content operation, RPC or notification transport protocol. So in content, just it can configure the data as we mentioned in the components of IoT device management with the network configuration. Next, operation, which type of operations can do, and RPC, remote process center, or notification, RPC underscore replay. It's transport, SSH and TSSH and TLC, the cell. So these are the some operator defined by Yango. Next, it is server. From the server, it can connect to the network configuration data store. It is Yang defined. So this is the basic diagram of network configuration, that is network configuration protocol. Next, what are the points involved in this diagram here? So network configuration works on first SSH, the secure shell. So it is RFC 4253. RFC 4253 protocol here. It is a transport protocol basically. That is the first point. Next, transport layer provides end-to-end. Which type of connectivity? It will provide end-to-end connectivity and ensure a reliable delivery of message. Reliable delivery of messages. Reliable delivery of message. It can provide. Next, network configuration uses XML encoded remote procedure calls. RPC stands for remote procedure calls for framing request and response message. So in order to receive the request and to send the response to each and every request. So it can frame the request and send the responses to the clients. So this is the third point. Next to RPC layer, a remote procedure calls layer. It provides mechanism for encoding of RPC calls and notification. RPC calls and notification, as we mentioned in the diagram here, RPC notification and calls. Next one, network configuration provides various operations to retrieve and edit configuration data from the network devices. We discussed in the last slide. Next, content layer consists of configuration and state data, which is XML encoded, as we mentioned in the third point already. Next, the schema of the configuration and state data. State data is defined in a data modeling language is called YANG. A network configuration provides a clear separation. It provides a clear separation of the configuration and state data. The last one, the configuration data resides within a network configuration data stored on the server. So these are the some real-time points of network configuration data protocol. So next one, introduction to YANG module. So here, introduction to the YANG modeling language. So it is a YANG. YANG is a basically one modeling language. Modeling language. YANG is a one modeling language. So YANG is a language that is designed to be readable by both humans and machines. It can be used for both readable. It can either be just we can read the by with our mind. So our missions in order to model the configuration and the state information. So in order to do the two types of operations here. So the first model configuration. Model configuration and state information. Model configuration and state information in order to do the two types of operation, that is the YANG model language. Next, YANG is rapidly becoming the standard way to model the network devices and network devices information. So it is the network device and network device information. So YANG is defined in the following RFC. So RFC 6020 YANG a model language for the network configuration protocol. This can be defined by RFC 6020. Next to RFC 6021, it is common YANG data types here, that is defined by RFC 6021. Next, RFC 7950. RFC 7950, the YANG version, 1.1 version of data modeling language. So these are the main things of just in order to define the YANG is a modeling language. So R depends on RFC 6020, RFC 6021, RFC 7950. So YANG is a model defines tree structure and data is mapped into this tree. A model is defined in the next file. It comprises a model, module, and optionally submodules which when compiled together from the tree model. So these are the some important points regarding YANG. Basically, YANG is a modeling language that can readable by both humans and machines in order to prevent or in order to do the model configuration along with the state information. So these are the some points regarding IoT YANG model language. So next, how to create YANG module by own. So here we have to create the YANG module by software. This is only theoretical part. So when go for tutorial part, so I am discussed. I will show the how to write the how to create the YANG module within the software. So this is only theoretical. Just I can explain how how it is works, how it is read. So here, in addition to the standard type of definitions detailed in RFCs, personalized type definitions can be created with the YANG modules. So create a file. It is called what is it is called? So engineer underscore types.yang. types dot yarn. So the content of the file should be as follows here. So this is the how to create your own Yang module. So in order to state the information and do the model configuration and state the information. So here the first letter start with module engineer. So it is for engineer. So module engineer underscore type the first. Let's braces begin. So Yang version, just we can define the which type of Yang version we are going to use for this writing this program. Next 1.1. Next namespace and inverted comma. First of all, urn.nokia.com sr expect dot types. So next, in order to define the prefix, which type of prefix we can use types. Next, revision. Revision nothing but date. Date you have to mention, define the date also. So type definition age type underscore. So it again begins bracket description. So engineers start work at 18 and should be retired at 120. So in order to define the in between the range between 18 to 110, the age should be between 18 and 110. So here the range of 18 to 110. So units here. So here next to type definition transport time. So which mode of transporting they are used. So here description method of transportation. So type enumeration. So one by one it can come. So either is enumeration food. Right? It can the mode of transportation by food, by bicycle, by car, by bus, by train, by boat, and by aeroplane. So the close basket three close. So these are the the basic create your own Yang module. So in order to define the engineers between 18 to the age between 18 to 110 age, along with the mode of transportation by food, by bicycle or by car, by bus, by train, by boat or by aeroplane. So which is they can use. So this is the first one, how to create your own Yang module. Next, what are the files it contain? So it having just we can here the first module type 1 version 2 prefix 3 and prefix 3 and mode of transport 4. So these are the some data types we are using here. So in order to explain that in theoretically, so the module name first, the module name they defined as the module engineer types section with engineer types being with the name of the new Yang module. So the first before that compulsory we have to insert the name and save the file. So then only we have to write the some programmatical steps. So this is the first step involve the name along with type. Next to prefix. The prefix, this is the short name that can be used within the Yang modules to quickly reference the module. Next revision number. Next revision number. This is in the format of a date should be adjusted when a change is made to the module. The revision number is returned to the operator when some specific RPs are made. So this is about revision. Next version. Just we are using 1.1 version of Yang. So here this is not version of the module but the version number of the Yang definition that author has written the module to currently this would be 1.0 to 1.11. Next this module can also contains two elements called type definition. These are the as the name would suggest the type definitions. The define custom types through the use of standardized Yang modules. Standardized types as defined in the RFCs could have been used, but for the purposes of the tutorial, we will define our own Yang module. So these are the some description point regarding the previous slide program. First, we have to mention the name. First, then version prefix name, then the revision. Next, Yang version and what are the definition types. So next one, creating the main Yang module here. So this is also same process. Just we have to define the first name, then prefix after prefix version, and some data types. The same like is here, took time to create the main YANG file that will be root of the module. So there is nothing specific in YANG that defines the root. This is not just depend on which YANG file you complete. So the module engineer, so same module engineer, YANG version, name same, up to here the same, prefix engineer, prefix types. So this is the date, here date. So the engineer container, it's me to here the leaf name and leaf age. So leaf committed. So in order to creating the main YANG module, so we have to define this type of data types like name, age, committed. These are the different name components of the company. So this is the how to create the main YANG module for different operations. Start with module engineer name. Any module consists with name. After that prefix. After that version. After that date. After that data type. So the last one transportation type. Closed brackets. So this is the creating how to create main YANG module with the help of this company name. Next, import the other YANG modules. How to import the other YANG modules? Just we have to describe. So as you recall, a module custom that type definitions was already created. So in order to use these types within the YANG module, the engineer types module needs to be imported. So we have to first we have to write the own we have to import the previous types. So to import a module, the import statement is used along with the module name. Module name of the YANG module is being imported. It is good practice to use the module name as the YANG file name. Next, import statement can include sub-options also. Sub-options also, we will define a prefix to be used within this YANG module can to reference in the external module. This will also allows for a shorthand notation with the YANG module. So these are the some statements regarding how to import the other from the other YANG modules. So these are the syntaxes. So import less than imported module name. Let's start bracket prefix. Just you can mention in this local prefix. So just from the local prefix module only we can import the some data. Next, in our tutorial example like this only, import engineer types begin. Let's prefix which type of parameters we are going to import from the previous local module. So these are the some other how to import the other YANG modules from the other one. Next, some data types here, list and choices. So here now we have a basic YANG module, custom types, and the number of leaves. Number of leaves. This module can be enhanced with some additional fields. Engineers works or projects and need to be eat and drink. So here the two operations eat and drink. So in order to do this operation on that, the first new information section will be a project. The project will be a separate branch in the tree, which means that it will be a container inside the engineer container. So this is the program to eat and drink for the engineer. So the engineer container, this is the engineer project. List works underscore item. So the keyword item name ordered by the user to eat and drink. The leaf work item name, it is a string type. So there's leaf close deadline and string close. So this is the in order to choose the project to eat and in the eat and drink. So for different variations by using list and choice. So these are some points regarding YANG module example. So the YANG module is a YANG version of the toaster MIB. The toaster YANG module begins with the header information followed by identity declaration, which defines various breed types. So the leaf node and the are defined the toaster container. So each leaf node definition has a type and optionally a description and default value. The module has two RPC definitions: make toast and cancel toast. Make toast and cancel toast. So these are the some steps involved in the to create your own module. Another the extended version of data types here with the date 2009-11. We already told first name, just you can define name, next prefix, version, date, data types, like that we have different steps. So same steps involved in this also. Toaster, type, breed, wheat breed, wonder breed, frozen waffle, frozen bagel has brown display string toaster. These are the sub things. Make toast and cancel. In order to make output input, in input we have some doneness toaster type different that. So the last finally we reach test done or toast status. So these are the things involved. Example of Yang module. In previous we real time how to create your own module, own how to create your own Yang module, and this is the creating main Yang module. So it is the combination of all the things will be happen. Next, importing other Yang module, importing some parameters from the other Yang module. Next, list and choice in order to eat and drink some kind of operations. Next, module example. So these are the some real-time Yang module explanation points. Next, understanding configuration data and state data. So here, these are the two types of data types. So let's data types here: configuration data and state data. So what is configuration data? What is state data? Before ending this lecture, so these are read and write configuration fields. For our interface example, this would be the interface name, IP address, subnet mask, and admin released and disabled, enable and disabled one. So state data defined. These are the read-only operational. So configuration data read and write, but state data read-only operational data fields. For our interface example, this could include a packet counter and operational state data physically up or down. So again, remember that Yang modules will only define structure of configuration, state data. So this is the thing you need to remember for Yang module. That it can define mainly structure of configuration, configured data, structure of configuration data along with statement data, state data. It will not contain any initiated or instantaneous value of the data, instantaneous value of the data. So it can already you can work on the already defined data, that is the configuration of data. So this is the some data types: configuration data and state data in the IoT Yang module. So these are the topics: IoT system management with network configuration with Yang module. So IoT system management having different types of components like IoT system management to configuration data, rollback manager, communication API, like that. We have different 9 components. Along with the Yang module, in order to, it is a modeling language. In order to do the operations for both human and machine can read the data. So these are the things of IoT system management with network configuration. IoT system management with network configuration with the Yang module importance involved in the IoT system management. So these are the things we completed. So these are the references I referred for this lecture from build in IoT management, device management for device management system for IoT for all. Next, some SCA paper also I referred, SCA paper and some Scopus paper also I referred for this lecture. These are the references for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.